Consider the compounds BCl3 and CCl4. How will they behave with water? Justify. Actually, BCl3 reacts very vigorously with water. Okay, it forms boric acid and hydrochloric acid. Wow, it releases HCl. Yes, it releases HCl. And what about CCl4? CCl4 doesn't react at all. How horrible. Yes, CCl4 plus H2O. You find no reaction at all at room temperature and pressure. With steam, superheated steam under drastic conditions around 500, 600 degrees Celsius, you find some reaction happens, but that is irrelevant here, that is not being asked. So in general, CCl4 doesn't react with water under normal condition. And BCl3 reacts very easily and vigorously. First, this is the first part. How will they behave? This is how they behave. Justify, we will justify. What happens? What happens is this, my dear. If you look at BCl3, BCl3 contains boron, B for boron and B for beggars. What do you mean? Boron has an incomplete octet of electron. It has only 2 plus 2 plus 2, 6 valence electrons. And it is always looking forward to 2 more electrons, and suddenly you find you add water. Water, although it's a simple molecule, but water always keeps on feeling rich because it has 2 lone pair of electrons. And boron, the moment it sees water, it says, oh my God, for heaven's sake, give me something. It says, fine, I have a lone pair, I'll give you a lone pair. BCl3 is such a huge molecule, water is such a small molecule. But if you have passion for donation and for service, even if you're small, you can do a very good job. Water donates its lone pair of electrons. Boron shamelessly accepts it. And what you get is this, B, Cl, 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 and O, H, H plus, like this. Boron acquires a negative charge because it has accepted a lone pair of electron, formal negative charge, only formal charge, not actual charge, and oxygen gets a formal charge of +1. Now starts the real fun. The moment boron gets a gain, chlorines also feel that, I am more electronegative, says chlorine atom. Boron, now that you are rich and you have electrons, I will steal your electrons and I will run away. How shameless. Yes, this is what chlorines say. We will run away and we will take your electron also. So what is happening is, if they run away, boron again would be left with just this much. H, H, it's like this. But when they are running away, the fun part is, hydrogens say, oh, come on, they're running away, we'll catch them. And suddenly, hydrogens also jump on them. And because they jump, one hydrogen jumps up and it tries to catch chlorine atoms. It tries to snatch. Now, hydrogen can jump only when it leaves its own electrons. So the poor hydrogen, it leaves its own electrons with oxygen. With bare hands, no electrons, hydrogen jumps and takes away this electron which is being stolen by Cl atom. Cl again is left with 3 lone pairs. One was being shared by hydrogen here. Since H has jumped here, it takes away 1 electron pair from Cl. Oxygen again, since 1 lone pair is there, it has taken 1 from H. O has 2 lone pairs like this. This is a reaction. Yes, this is a reaction. Please note, in BCl3, 1 Cl has been replaced by 1 OH group. Wow, that is fantastic. Yes, it is fantastic. The same reaction can be repeated twice and thrice. And repeated 2 more times, you get B, OH, OH, and OH. You get 3 hydroxides like this. And if you have 3 hydroxides like this, my dear, is your good old and very lovely boric acid. This is the source of reaction here. With complete details of mechanism, I have explained you why this reaction happens. But all of this begins with incomplete octet of boron. Boron is able to interact with water. Boron is able to react with water because boron was hypovalent, its octet was incomplete. If you consider CCl4, you would notice that Both carbon and chlorine have complete octets. There is no place for carbon to accept a lone pair of electrons from water molecules. It is a second period element. Carbon also cannot expand its own octet. Since there is no place for lone pairs to be accepted, CCl4 cannot function as a Lewis acid. Yes, it cannot begin to react with water. And that's why, my dears, it doesn't react with water. So this is also a very beautiful reason why CCl4 is inert towards water, while BCl3 reacts very vigorously with water because of incomplete octet of boron and complete octet of carbon.